Nearly 2,000 years ago, temple doors in the Roman world opened by themselves. No hands touched them. No visible force moved them. Priests would light a fire on an altar, and moments later, heavy bronze doors would swing open, as if the gods themselves had commanded it. Worshippers would gasp. Some would fall to their knees. The crowd never knew the truth. It wasn't magic. It was a machine. Today, we're asking a question that sounds almost too strange to be real. Did the ancient Roman world build machines that could move, react, and perform tasks on their own, centuries before anything resembling a robot was supposed to exist? Not myths, not legends, actual devices built by real engineers, some of which still baffle historians today. By the end of this video, you'll understand exactly what these machines were, how they worked, why they were built, and why the answer to our question is far more fascinating than a simple yes or no. To understand this story, we have to step outside the image of Rome most people carry, legions, senators, gladiators fighting in the sand, and step into a very different Rome, a Rome connected by trade, conquest, and culture to the brilliant Greek scientific tradition of the Hellenistic world. When Rome expanded into Egypt and the Eastern Mediterranean, it didn't just gain territory, taxes, and grain. It inherited some of the greatest engineering minds on Earth, centered in one extraordinary city, Alexandria. Alexandria wasn't just home to a legendary library. It was a workshop for invention, a place where mathematicians, physicists, and inventors were funded to experiment, build, and push the boundaries of what machines could do. And under Roman rule, that workshop didn't shut down. It kept running, kept producing, and kept surprising people. The first major figure in this story is a man named Hero of Alexandria, who lived and worked during the 1st century AD, squarely under Roman control in a city thriving under Roman administration. Hero wasn't a mystic or a philosopher lost in abstract theory. He was a practical engineer, closer in spirit to a modern inventor than an ancient sage. And he left behind something remarkable: detailed written manuals describing machines he actually built, in a text historians now call automata, alongside another influential work called Pneumatica. In these texts, Hero describes self-moving devices powered by weights, pulleys, compressed air, and water pressure. Nothing supernatural, just clever applications of physics most people at the time didn't understand. One of his most famous creations was a small mechanical theater, roughly the size of a large cabinet. This self-contained box, once triggered, would perform an entire short play on its own. Figures moved across a tiny stage. Doors within the miniature scene opened and closed. A mechanical bird even sang at the appropriate moment, all without a single human hand guiding it in real time. Someone had to design the sequence and wind it up beforehand, but once the performance started, it ran entirely on its own, following a fixed program of actions. This wasn't science fiction, and it wasn't exaggeration passed down through legend. This was documented engineering, sitting in Roman Egypt, roughly 1,700 years before the Industrial Revolution would supposedly introduce the world to automated machinery. Here's where it gets even stranger. Hero also designed something called the aeolipile, a simple steam-powered sphere mounted on an axis that spun rapidly when heated over a fire. Steam would escape through two angled nozzles, and the reaction force would send the sphere spinning at surprising speed. It's often called the world's first steam engine. But here's the twist most people don't expect. Hero never used it to do useful work. It wasn't connected to a wheel, a mill, or a pump. It was built as a novelty, a demonstration of principle, almost a toy meant to amaze wealthy patrons and curious visitors. Think about that for a moment. The basic concept behind the steam engine, the very technology that would eventually launch the Industrial Revolution and reshape human civilization, existed in the Roman world, fully understood on a theoretical level, and it was treated as entertainment, a clever curiosity rather than a tool. So, why didn't ancient Rome build an army of steam-powered machines centuries early? The answer isn't a lack lack of genius. Rome clearly had brilliant engineers capable of extraordinary precision. The real answer is a lack of motivation and infrastructure. Roman society ran on an economy built heavily around slave labor. There was little economic pressure to replace human hands with machines because human labor was already treated as cheap, abundant, and expendable. On top of that, precision metalworking was still fairly limited by later standards. Hero's devices worked beautifully as small-scale demonstrations, but scaling them up into powerful, reliable machines capable of real industrial work required manufacturing tolerances the ancient world simply didn't have the tools to achieve yet. Still, the underlying ideas didn't disappear. They spread. Roman temples across the empire began adopting similar mechanical principles, using heat, air pressure, and hidden internal mechanisms to create the illusion of divine power for religious ceremonies. That trick with the self-opening temple doors from the very beginning of this video? Historians believe it worked through a heat and water system, very likely inspired by principles Hero himself described in his writings. Fire on a hidden altar would heat air trapped inside a sealed chamber below the temple floor. The expanding air would force water through a hidden pipe into a container on a system of pulleys. As that container filled and grew heavier, its weight would trigger a mechanism connected to the massive bronze doors, slowly swinging them open as if by unseen hands. To an ordinary Roman citizen standing in that temple courtyard, watching heavy doors move without explanation, it looked exactly like a miracle, proof that the gods were listening. To an engineer standing behind the scenes, it was simply physics, carefully hidden from view. But automata in the ancient world actually go back even earlier than the Roman period. And this next detail matters because accuracy requires giving proper credit where it's due. Centuries before Hero was even born, a Greek mathematician and statesman named Archytas of Tarentum reportedly built a wooden mechanical bird, sometimes referred to as the pigeon, that could allegedly fly short distances using compressed air or steam power. Ancient sources describe this device with genuine detail, but no physical evidence has ever survived to confirm exactly how it worked, or whether it worked as dramatically as described. Historians treat it as a documented historical claim rather than a fully confirmed fact. This matters because it reveals something important about this entire story. The idea of self-moving machines wasn't a Roman invention at all. It was a Greek intellectual and scientific tradition that Rome later absorbed, funded generously, and preserved for centuries, especially once Roman rule stabilized Alexandria as a lasting center of learning and craftsmanship. Calling these devices simply Roman robots, as our title playfully suggests, actually oversimplifies a richer truth. The original genius behind these concepts was largely Greek, the empire that gave that genius a stage, resources, protection, and remarkable longevity was unmistakably Roman. And it wasn't only small novelty devices built purely to entertain wealthy patrons. Roman engineers and their Greek predecessors also built genuinely complex automated systems tied directly to everyday practical life. Water clocks, refined by an earlier Alexandrian engineer named Ctesibius, used a steady, controlled drip of water to power moving figures that marked the passage of time with real precision. Essentially, automated clock displays functioning centuries before mechanical clockwork would appear in medieval Europe. Roman public spectacles sometimes featured elaborate stage machinery, capable of raising and lowering entire sections of scenery, simulating storms with mechanical sound effects, or making objects appear to move across a stage on their own. Engineering achievements built purely to astonish a paying audience, not entirely unlike the practical special effects used in modern filmmaking today. Perhaps most astonishing of all is a device that isn't technically Roman in origin, but still reveals just how advanced this era's mechanical thinking truly was. The Antikythera mechanism, discovered by sponge divers inside an ancient shipwreck near the Greek island of Antikythera. This small bronze device, built somewhere around the 2nd century BC, contains dozens of precisely cut interlocking bronze gears designed to predict astronomical events, including solar and lunar eclipses and the shifting positions of visible planets. It is, in essence, an ancient analog computer, built with a level of mechanical sophistication the historians once once assumed simply didn't exist that early. Nothing close to its complexity would reliably appear again in human history for well over 1,000 years. So let's finally answer the question directly. Did ancient Rome have early robots? Not in the way modern robots work. And it's important to be honest about that distinction. There was no artificial intelligence involved, no autonomous decision-making, no machine capable of genuinely sensing its environment and adapting its behavior in real time. Every single device required a human being to design it, carefully build it, and manually set it into motion before it could perform its function. But if we define the word a little more broadly, a machine capable of performing a pre-programmed sequence of actions without any direct human control during that sequence, then yes, the Roman world absolutely had them, in impressive variety. Self-opening temple doors, mechanical theaters that performed entire miniature scenes from start to finish, steam-driven spinning spheres demonstrating real physical principles, automated water clocks marking time with mechanical precision, bronze computers hidden for 2,000 years inside a shipwreck. These weren't isolated curiosities scattered randomly across the centuries by pure coincidence. They represented a genuine, connected tradition of mechanical thinking, one that Roman political power, immense wealth, and vast infrastructure helped preserve, refine, and spread across an empire that stretched from the misty hills of Britain to the deserts of Egypt. The truth here is almost more remarkable than the myth our title suggests. Ancient engineers weren't stumbling onto these ideas by blind luck or happy accident. They understood pressure, weight distribution, precise timing, and mechanical sequencing well enough to deliberately build devices that could genuinely surprise, entertain, and even convincingly deceive an audience that had absolutely no concept of automation. What stopped this remarkable technology from evolving further wasn't a failure of imagination or a lack of raw talent. It was the simple absence of the right economic incentives and industrial conditions that wouldn't properly align again for well over 1,000 years, until the Industrial Revolution finally picked up threads that the ancient world had already begun weaving quietly in the workshops of Alexandria. So the next time you picture ancient Rome, don't just imagine marble columns, marching legions, and crowded arenas. Somewhere in a quiet Roman temple, a hidden mechanism was carefully turning fire into motion. Proof that the dream of machines doing what only human hands once could is far, far older than most of us ever imagined.